students, today we're going to be talking about the linear equations, student handout 3. So again, we are still doing some of the review concepts that we had learned in prior years or prior chapters. So the first thing is I want to make sure that you have your first and last name on your sheet of paper. And I also want today's date and the period in which you have math. So we're going to talk about 1- and 2-step equations. This was definitely a whole unit within your 7th grade year, so let's refresh your memory. Let's just talk about the parts of an equation. What are you looking at when you see an equation like this? So anytime you see two things together, if you remember, that's a coefficient. Co meaning a duo, kind of like co-teacher, cooperation. You're doing something together. When you have the coefficient, or if it stands alone, it doesn't matter, that letter is always a variable. And then this standalone creature that is a number is your constant. So then you have your equals, and then you have your total amount. But the main thing I need you to learn is those words. This is a coefficient. So this whole thing is the coefficient. The variable is just the letter, and any number that stands by itself is a constant. So let's talk about how to solve a one-step equation. So to solve a one-step equation, you need to isolate the variable by using inverse or opposite operations. And I'm giving you the definition because I want you to use the term inverse, but I want you to know that it means opposite. So isolate the variable with an inverse operation or opposite operation. Now, the difference between a one-step and a two-step is that we add a little bit to it. So the first step in a two-step equation is use addition or subtraction to remove the constant. Let's talk about PEMDAS really quick, and I want you to write it out to the side. PEMDAS. So here you have addition or subtraction. The addition or subtraction depends upon what you read first, especially when it comes to multiple. So this portion is you're doing first. Then multiplication or division in order to remove it. Oh, that's a pink one again. Let's see if I can find another color. I could have orange. So on a two-step equation, you're going to work your way through and do this second. Now, the parentheses or exponents, that's for when you have multiple step equations, but I just want you to remember that you're almost working through PEMDAS upside down. SAD-MEP. You're going to go through this in the opposite order in which you typically know the PEMDAS. Alright, so let's go back to filling in notes. So the second, use multiplication and division to remove the coefficient. I need to isolate the variable, and so I cannot have a coefficient in the problem when the variable gets isolated. So tip, if dividing by a fraction, multiply the reciprocal. And you've seen that before. It's probably just been a while since you've seen that word reciprocal. Reciprocal is, again, an opposite or flipped. So you're looking at a reciprocal. If it's 3 over 1, it becomes 1 over 3. That's a reciprocal, the flipping of a. Okay, so if dividing by a fraction, multiply by the reciprocal. Again, all of these words should be pretty familiar to you. You've probably heard me say them a lot. Sorry, I want to separate that so it didn't look like a B. Okay, so let's take a look at solving the following one-step equations and show all work. I want you to spell it out for me what it looks like. So here I have x over 1/5 equals 16. In this case, I am going to multiply by the reciprocal. So it becomes 1.5 over 1 and times 1.5. The reason why I just did 1.5 is because they're both over 1. so technically I don't need to worry about adding the 1. I'm just a lazy mathematician. Sorry. So when you're multiplying this, you're going to be able to go ahead and do the reduction. These cancel each other out, so that's 1 and 1. So all around I have nothing but 1. So I have 1x equals, and I'm going to get 16 times 1.5. I'm going to get 24. And technically, I don't need that 1 right here, and I am a lazy mathematician, so I'm going to go ahead and just put x equals 24. So it's isolating that variable. And since I don't need or have to put the 1 right here, it is isolated. It's just an understood 1 that's right here. And the x itself, there's only one x, so I already know that. There's no need to state it twice. So since this is a refresher for you, I'm going to go ahead and make everything else your student-led work. I want, student-led work, and I want you to go ahead and complete 2 through 6 independently. Please come see me and check off that you are headed on the right path. If you have any questions, please come see me. But in the meantime, pause the video and finish your student-led work. Okay, so now that we have 1 through 6 completed, let's talk about how to write and solve a model by the following. So here, it's not a complicated process. You just have to kind of think your way through just a little bit. So what you're looking at is here I have 2 full items that have x in them. And then over here, mainly just because it's easier to do smaller, you have 6 of these. They are negative. So how many negative x's do you have? Well, I have 2 of them. So they are negative, and there's 2 of them, and they labeled them x's. So I'm just going to translate this picture into actual equation. I have an equals, so it's the same thing over here, which equals, and then in my small boxes, they're all negative 1s, and I have 6 of them. So I have negative 6. This could also be the same if I were to say negative x plus negative x equals negative 1 plus negative 1 plus negative 1 plus negative 1, 2, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, it's the same thing, but since I know eventually, even if I were to type this into a calculator, I'm going to get this, I just took the shortcut of thinking my way through. They're both negative, there's 2 of them, and they have an x. There's 6 of them, it's negative, so negative 6. Now, if I were to find my solution, I would use the same methodology of keeping a balanced equation. I'm having a multiplying relationship here, so therefore I must divide, and I do it by fraction because 1, it saves me space, and 2, I can easily read negative 2 divided by negative 2 is 1, so I'm left with x, and 6 divided by negative 2 is negative 3. Oh, I forgot my negative here. No wonder why I'm goofing up. Sorry about that. So 6 divided by 2 is 3. There's 2 negatives. Therefore, it's going to equal positive because anything that has the same symbol for multiplication or division is always going to be positive. So my answer solution is x equals 3. So make sure if you were to work it over here, like you copy it correctly, like I did not. I forgot the negative to begin with. Okay, so let's flip your sheet over. Here we have the following 2 steps equation. I'm going to show you that balanced equation one more time, and then I'm going to have you work through the rest of them independently. So remember, step 1 is going to be the PEMDAS of add or subtract first. And so I'm going to subtract 14. There's not a negative here, and in order for it to be a negative, it has to have one. So the inverse operation of an automatic addition is a subtraction. 14 minus 14 is 0, and negative 13 minus 14. If you remember the rule for adding or subtracting a negative, you're going to add the numbers together. So I'm going to end up with 27, and keep this symbol. So it's negative 27. then I have 9m. For this, I have a multiplication relationship. I must divide, equals 1, and negative 27 divided by 9. In a negative positive relationship, I'm going to keep the negative, and m will equal 3. So if you need to keep a balanced equation, equals negative 3. Just remember your rules for inverse. You'll always need them in any math that you use from this point forward. So just remember that. M equals negative 3. All right, so the rest is student-led because this is review. So, I'm sorry, I can't seem to write student correctly this morning. I'm sorry. Student-led. And please ask any questions that you may have on 9 through 13. I'd be happy to help you. So go ahead, pause the video, do the student-led portion, and then come. Okay, welcome back. So hopefully that was pretty easy for you, and if it wasn't, you came to see me. So the model portion is, to me, a little bit easier. We are trying to do a balanced. So if we are balancing the equation, we must, this representation right here is going to be the equals. So that's what I'm going to give you a helpful hint. So I'm actually going to work through number 14 on the word problem. On a beach trip, Lucy rents a bike from Wheels by the Waves, where they rent bikes for $12 plus $3 per hour. If Lucy spent $30, how many hours did she rent a bike? So she spent $30. So spending $30 means that I automatically, that's how much I paid out. That's what it equaled. Okay, so the next part is I know that you can rent a bike for the $12. No matter what, you have to pay $12. So I'm going to add $12 to the amount per hour, because regardless, that's what I'm paying. Now, I also know that I have per hour, and h equals hour, so it's 3h is going to be the same as $3 per hour. So the other information is 12 plus, then 3 per hour. How many hours? So I'm going to have to do a little math, and I'm going to have to create an equation over here and balance my equation to find my solution. But I do know that I'm looking at the same type of two-step equation that I had been up here once I find my information. The rest of this didn't necessarily matter because I wanted to just translate the information to an equation. So here I have 3h plus 12 equals 30. Keeping that balanced equation, I'm going to do my addition or subtraction first, and I'm going to be left with 3 hours is equal to 30 minus 10 is 20, minus 2 more is going to be 18. So dividing, because the relationship is multiplication, my hours is going to equal 6. So my solution is going to be 6 hours is how long she spent on that bike when she spent only $30. So the same could work in real life if you were to say, okay, I have $50 to spend. I know that for $12 is going to be the amount I have to spend. How many hours can I rent it for? You can use the same type of equation based on how much money you have. So if they had worded it differently, it could be very similar to what you would need to figure out and the process in which you would need to figure out on your own problem. So I want you to use the same methodology. Here's what I know. Here's what I know. Here's what I need to know. Plan and work. Write your equation right here. And then your solution. Use that same process every single time you have a word problem. Go ahead and do 15 and 16 on your own. Pause the video. Come check and see that, make sure you're headed on the right path, that you have the same mathematical mind to complete this correctly. And then come back to the video so I can walk you through summarizing today's lesson. Okay, so let's talk about summarizing today's lesson. If we go back to the beginning, we were talking about 1- and 2-step equations. So I need to have you tell me what the 1- and 2-step equations are. Explain that to me. Use the idea of a 1-step equation typically has a coefficient, and a 2-step equation will include the constant and a coefficient to equal a total. So I want you to be able to explain that to me. The other thing is I want you to be able to explain to me how it is to solve a one-step equation. What part of PEMDAS are you typically using? How do you do that? Keep a balanced equation. You should have terms like that within there. Then the third sentence you're going to work on is I want you to walk me through a two-step equation. How are you going to use PEMDAS to solve a two-step equation? What's important about keeping a balanced equation? How do you do that? So you should have a statement about solving two-step equations is easier when you, or can be done when you, or is simply da-da-da-da, however you want to phrase it. The last thing I want you to tell me, there's now 4 sentences you're going to have, is I want you to tell me the methodology on which we solve word problems. I want you to tell me about how you locate what you know, what you need to know, your plan of work, and your solution. Once you are able to work through that for me, you'll have your full summary. So your full summary is a 4-sentence minimum. I'd be happy for you to have more, but it's at least 4 sentences, which means in order to have a sentence, you have a capital letter, end punctuation, a subject, verb, and it has to make sense. Go ahead and mark your sentences in your head to make sure that you got it right. All right, and look for the next video on your homework help.